other room. I'm not quite sure how to really deal with rooms without excessive clutter. So as was mentioned, the electrostatic lab pulled the stuff off the video as opposed to our actually conducting it. So I know there was one person who wanted to actually conduct it, and so apologies. I will say, in terms of the final results, for the information I pulled off the video, I was under 100% off, which for that lab was a huge victory. I suspect if I redid it in this time of year as opposed to doing it in May, I might get better results, but it is where it is. Any questions before we begin?
So is it still due next Wednesday though, right?
That would be lovely, but I understand also it did not send out the email like I had intended. So Wednesday would be lovely, but I would also understand Friday. If there's a personal issue that you have with that because of this, that, or the other, just talk to me. We can figure out what works for both of us. So before we get into the 2 protons in the universe, we'll sort of refresh our memories about adding vectors within the context of this particular course. So, did I give adequate time for anyone else have any questions? All right. So I have 3 non-collinear charges here. We'll make this 1 microcoulomb, 2 microcoulombs, -3 microcoulombs. We'll make this distance here 4 centimeters, 5 centimeters, and 6 centimeters. Obviously not drawn to scale. So let's find the force on the 3 Coulomb charge. I'm just going to label that as F sub 3. All right, so first off, when you're dealing with, well, a lot of the things in this course, since we're dealing with vectors, there's obviously direction involved. So let's think through the directions. What is the direction of the force on this 3 microcoulomb charge from the 1 microcoulomb charge?
.06 meters. Oh, you said direction or
the direction.
Oh, direction.
In terms of r hat?
In terms of pointing.
And being pulled towards, or -3 and 1, or going towards.
Okay, that's what I was going for.
Oh.
So it's being, that force is in that direction. I'm just going to label that F. The force on 3 from 1. What about the force, direction of the force on the -3 microcoulomb charge from the 2 microcoulomb charge?
Still towards each other.
Now, these are also, by Newton's third law, we would expect those to also be attracted there. And the direction of the force on the 2 microcoulomb charge from the 1 microcoulomb, since we're here. All right, go on with the hand gestures. But I'm only interested in terms of what we're doing right now on the 3 microcoulomb charge, or -3 microcoulomb charge. Now the negative sign, ultimately, when you plug into Coulomb's law, is going to give you a direction, but we've already thought through the direction, so we don't really need to pay attention to the negative sign, other than the fact that it's telling us the direction of the pull. So this would be the force on 3 from 1 plus the force on 3 from 2. Well, magnitude of charge, that's simple enough. That's a plug and chug. what is the formula for the magnitude of charge?
K times Q1 times Q2 over R squared R3 hat.
Just the magnitude. The force on 3 from 1 would be R1 hat, and the force on 3 from 2 would be R2 hat. So plugging in for the 1-2 combination there, we have 9 times 10 to the 9th. Q1, but one of them is Q1. 3, what is micro anyway?
10 to the negative 6.
Okay. E negative 6. 1 E negative 6 divided by 0.06 squared. Someone be kind enough to crank that out. And the other one, so this would be 3-1.
I have 7.5. I've forgotten the units. Newtons.
I hope so.
Yes.
7.5, anyone else? Waiting for confirmation. All right, so while people are confirming that, the other one, the F32, 9 times 10 to the 9th, 3 times 10 to the negative 6th, 2 times 10 to the negative 6th, 0.05 squared. All right. All right, at big values, that would actually, we didn't have to deal with it times 10 to the.
I have 21.6
Same.
All right.
newtons.
Now, I would have expected that this one would have been a larger value conceptually from 2 reasons. One, I'm dealing with this is twice as big as this is, and also it's a little bit closer. All right, so I now have the magnitude of forces, but in order to add vectors, I need to know direction. In essence, I need to, well, figure out angles. What is that angle? What is that angle? I'll call this cleverly theta 1 and theta 2. If you'd rather do the angles from the vertical, have at it. Just, you need to know either the angle to the horizontal or angle to the vertical. Well, I guess we could have, there is another way of doing it that's not necessarily simpler, but we could shift our coordinate system so that I don't need to know the angle between those two. But we're here now. So how would we find those? Besides magic. So in essence, we're trying to find that angle there. Did I make this more difficult than I needed to be?
You gave us a known angle. 50 degrees.
Oh. Oh, this is a fun little problem. How would we solve it? Who said trig? At least one of you. It's the people who I suspect who are just don't want to admit to it right now.
The words side angle side come to mind, but I don't know what to do with that.
Say it again?
Side angle side was what came to mind, but it's been a while since I.
Well, we're trying to find this angle here or this angle here. So you have side angle side here. Actually, we don't know this side. Well, I guess we know that side right there.
So we can cut it in half, find the right triangle. And
Oh,
go there.
That's a,
No,
because we don't know where this
1.65.
actually hits.
Right.
It's not like it's 2 centimeters, 2 centimeters.
Right.
I know you're going to get excited by this because we really haven't done much with it. Law of cosines.
Oh my. Okay. Well,
Yeah, that, I assume that oh my was, there was an excitement underlying
Yes,
that.
of course.
Who remembers law of cosines? If the angle that you're dealing with in law of cosines is 90 degrees, what do we call that formula?
Pythagorean theorem.
Yes, it is. Pythagorean theorem is a specialized case of law of cosines. So if I have a triangle here, and we'll cleverly label this A, B, and C, and this angle, oh, what the heck, theta. A squared equals B squared plus C squared minus 2AB cosine, oops, sorry, not AB, BC cosine of theta. Pythagorean theorem here, and then we have this little adjustment for the fact that it's not a right triangle. This is the angle opposite that length. Now, it was not my intent when I first wrote this up here to do a law of cosines problem. I'm hoping that it that at least looks somewhat familiar to those who have had trig. For those who have not had any trig, then this is called the law of cosines. I know I've done a video about deriving it. I just don't remember if I have it posted for one particular or not. So we have 5 squared equals 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of theta. I guess theta 1, given the context of our problem over there. So 36, 16, 52. So that would be negative 27 divided by, so that's roughly somewhere around 60 degrees.
About 55.77 degrees.
Okay. It seems reasonable. Anyone else get the same thing? And there you were bad-mouthing our calculator last week.
Come at me.
It wasn't me.
No, didn't.
All right. Anyone else get this? Are we just going to go back to bad-mouthing our calculator again, or
That's correct.
you like that one?
Yes, sir.
Okay. But in order to do that, you need to come up with a different number.
No.
I'm just going to go with what she has unless somebody corrects it. I guess they have such faith in you now.
I guess.
That's what a week off will do. So I now know this angle here. So in essence, I have the magnitude of 7.5 newtons. 7.5 newtons. at an angle here of 55.77 degrees. Let's do the other one. So that angle is the same angle as down here. That's theta 1. Oh wow, cosines are so much fun. Let's do it again. I think that's actually going to be the simplest way once you recognize that you can use this formula here. So now it's going to be 6 squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of theta 2. We also could have done law of sine since we now know one of the angles, interior angles. It should be steeper. So 75 degrees. While you're calculating that, look my head in the hallway just in case there's.
I have 82.8 degrees.
82.8?
Yeah, I got the same answer.
All right, there we go. And then I have this other force going down at that angle right there with a magnitude of 21.6 newtons and an angle of 82.8 degrees. Now there are a couple ways that we can write this. We can leave it like that, and if I were doing this on my own, from there I would just go ahead and start doing. I would break it up into components. Or if you prefer something more formal, there's no doubt students always prefer it more formal. The problem we're dealing with here is 7.5 newtons. See, 180 plus that, so that's 235.77 degrees plus 21.6 newtons, negative 82.8 degrees. So that's a formal way of presenting the sum of these two vectors in polar form. Guess we don't need this anymore. Or we're breaking it up into perpendicular components. Dusting off the cobwebs. Which trig function is going to be associated with this component?
Sine.
Or?
Tangent? Because that's the adjacent side.
It is the adjacent side.
Oh, I'm sorry. I was completely wrong. It's cosine or tangent.
There we go. Yeah, it's cosine. And this one?
Sine.
We're on a roll. This one? In unison would be really cool right now.
Cosine.
I guess that was better than before, but, and this one?
Sine.
Oh, that was nicer. Not the chorus of angels yet, but we'll get there. So we are breaking this up into components, and so we have 7.5 times the cosine of 55.77, and 7.5 times the sine of 55.77 degrees. And then 21.6 cosine of 82.8 degrees, and 21.6 times the sine of 82.8 degrees. So we probably should, in order to express our final answer, I was figuring I was gonna just leave it in rectangular form, so we need an I hat and a J hat. Need to define these directions, so why don't I just stick with the brainwashing that I've been taught so long? And just go with the traditional to the right and up being positive. And so I got 4 different components here. I can make up answers, but it'd be nice to actually have real answers. Has anyone done them yet?
Dr. Bob,
Yep.
is that 55.77?
Yes.
Okay.
Should be that number.
Okay.
Assuming we can believe Anna when she told us that.
Stand by it. I also stand by every mistake I've ever made as being a personal error and not a calculator error, just so we're clear.
No, I guess I was giving you the benefit of the doubt instead of the calculator.
Don't forget the Russian proverb. Trust but verify.
Mm-hmm.
Anyone? Your?
For the adjacent side of that one, yeah, I got 4.22.
4.22?
Yes.
Negative I hat.
And negative given I had given the dimension I set up over there.
And then for the opposite side, I got 6.2.
6.2.